October 17, 1943, Ruhr Valley, Germany. A Luftwaffe armaments technician named Oberfeldwebel Werner Schultz crouches beside the twisted fuselage of a downed RAF Lancaster bomber, his gloved hands carefully examining a small, cylindrical object, no larger than a pocket watch lodged in the aircraft's electrical housing. The device weighs barely 4 ounces. Its casing is stamped steel, crude by German engineering standards. Yet within 24 hours, Schultz's discovery will circulate through every Wehrmacht technical intelligence office from Berlin to the Atlantic Wall. This is the British Type F pocket incendiary bomb, and it represents something the German military had not anticipated. A weapon so simple, so inexpensive, and so devastatingly effective that it would force a complete revision of industrial sabotage countermeasures across occupied Europe. The Type F pocket bomb emerged from the Special Operations Executive Workshops in Station 9, Welwyn, Hertfordshire, in late 1942. Britain's sabotage warfare program, orchestrated under the Ministry of Economic Warfare, had identified a critical vulnerability in the German war machine. The Reich's industrial capacity depended on millions of forced laborers, occupied factory workers, and subjugated populations across France, Belgium, Holland, Poland, and Czechoslovakia. Traditional resistance operations required weapons, explosives, and training that were difficult to deliver. What was needed was a device so simple that any individual could deploy it, so concealable that it could evade search protocols, and so reliable that untrained civilians could strike at the heart of German production. The answer was a thermite-based incendiary no larger than a fountain pen, producible for less than 2 shillings per unit, capable of burning through steel at 2,500 degrees Celsius. The Type F measured precisely 5.5 inches in length and 0.75 inches in diameter. Its outer casing consisted of a drawn brass or steel tube, sealed at both ends. Inside, a tightly packed thermite compound, aluminum powder and iron oxide in precise stoichiometric ratio, surrounded a delay mechanism of remarkable simplicity. A soft copper wire held under tension by a coiled spring restrained a spring-loaded striker pin. Once activated by crushing a small glass ampoule of cupric chloride solution, the acid began corroding the copper wire. Depending on wire thickness, the delay ranged from 10 minutes to several hours. When the wire corroded through, the striker ignited a first-fire composition of barium chromate and powdered aluminum, which in turn initiated the thermite reaction. The result was a compact inferno that could melt through engine blocks, turbine housings, electrical transformers, and machine tool components with surgical precision. British intelligence calculated that if even 1% of occupied workers could be equipped with pocket bombs, German industrial output would face systematic degradation impossible to counter through conventional security measures. The devices were dropped in their hundreds of thousands across occupied territories beginning in spring 1943. RAF Bomber Command modified Halifax and Stirling aircraft to carry specialized containers holding up to 500 Type F devices per sortie. Drops occurred during routine bombing operations, the small munitions scattered across urban industrial zones, railway yards, and manufacturing districts. Simultaneously, SOE agents distributed thousands more through resistance networks. Instructions were printed on rice paper, dissolvable in water, explaining in French, Dutch, Polish, and Czech how to activate, conceal, and deploy the weapons. The guidance was ruthlessly practical. Place in coal bunkers to destroy boilers, insert into gearboxes to seize machinery, drop into oil reservoirs to contaminate lubricants, wedge into electrical panels to create cascading failures. The German response revealed the weapon's true impact. By November 1943, the Reichssicherheitshauptamt, Reich Security Main Office, issued Directive RSHA 4E5, mandating comprehensive searches of all industrial facilities in occupied zones. Factory guards were ordered to inspect lunch pails, toolboxes, and personal effects daily. New regulations prohibited workers from carrying any metal objects not directly related to their assigned tasks. Lighting in sensitive areas was increased. Patrol frequencies doubled. Random searches became standard procedure. The administrative burden was staggering. A single large factory in the Renault works outside Paris required an additional 120 security personnel operating in rotating shifts. Across occupied France alone, the German military government estimated that pocket bomb countermeasures consumed over 15,000 man-hours per week by early 1944, diverting resources from frontline units and occupation enforcement. German technical intelligence subjected captured Type F devices to exhaustive analysis. Reports from the Waffenprüfamt, the Army Weapons Agency, expressed grudging admiration for the design's efficiency. The thermite composition required no special handling or storage conditions. The acid delay mechanism functioned reliably across temperature ranges from -20 to +40 degrees Celsius. The device's small size defeated most detection methods available in 1943. Metal detectors of the era lacked sufficient sensitivity to distinguish a pocket bomb from ordinary tools or personal items. X-ray equipment was too scarce and too slow for mass screening. Guard dogs could not detect the odorless chemicals. The only reliable countermeasure was manual search, which proved both time-consuming and incomplete. Even when searches were conducted, workers quickly learned to conceal devices in false bottom containers, hollow boot heels, or sewn into coat linings. The strategic mathematics worked decisively in Britain's favor. Each Type F cost approximately 2 shillings to manufacture, less than the price of a single .303 rifle cartridge. A successful deployment could destroy machinery worth thousands of pounds and halt production for days or weeks while repairs were completed. The replacement cost for a single machine tool might exceed 50,000 Reichsmarks. Turbine damage could idle an entire factory. Transformer destruction could black out production facilities for months given wartime replacement delays. British analysts estimated that for every 1,000 devices distributed, at least 50 resulted in significant industrial damage. The return on investment was extraordinary. A single Halifax bomber sortie, dropping 3,000 pocket bombs across the Ruhr, might cost 500 pounds in munitions, but could generate production losses equivalent to a major conventional bombing raid, costing millions. German countermeasure documentation grew voluminous. The Wehrmacht issued technical manual Merkblatt 47.3, Erkennung und Bekämpfung von Sabotagewaffen, Recognition and Combat of Sabotage Weapons, running to 127 pages by its fourth edition in March 1944. Detailed drawings illustrated the Type F alongside other Allied sabotage devices. Instructions specified immediate flooding of any thermite fire with dry sand or magnesium-based extinguishing powder. Water would cause violent steam explosions and spread molten iron. Factory managers received directives to establish isolated containment areas where suspicious objects could be safely detonated. Specialized disposal teams were trained at facilities near Berlin and Munich. The administrative apparatus required to counter a device weighing 4 ounces became a bureaucratic monster consuming thousands of personnel hours across occupied territories. Resistance organizations embraced the pocket bomb with enthusiasm bordering on reverence. In occupied France, the Maquis integrated Type F devices into systematic campaigns against German logistics. Railway workshops became prime targets. A single device placed in a locomotive's firebox could crack cylinder heads and destroy precision valve assemblies, requiring weeks to replace. French railway workers, many of whom had worked on the same locomotives for decades, knew exactly where to place thermite charges for maximum effect. The result was a steady degradation of rolling stock availability. By mid-1944, German military transportation reports noted that serviceable locomotive numbers in France had declined by 18% despite intensive repair efforts, with sabotage accounting for a significant proportion of the losses. In the industrial cities of the Ruhr, German workers themselves began obtaining Type F devices through underground networks connected to Allied intelligence. The psychological impact was profound. German authorities faced the realization that sabotage could come not just from conquered populations, but from within the Reich itself. Security measures intensified to levels that impeded production efficiency. A machine shop that once operated with minimal supervision now required constant monitoring. Worker morale declined under perpetual suspicion. Production quotas, already strained by Allied bombing and material shortages, fell further as security procedures consumed manufacturing time. The Armaments Ministry under Albert Speer acknowledged in internal memoranda that sabotage countermeasures were themselves becoming a drag on industrial output. Technical evolution of the pocket bomb continued through 1944. The British developed the Type F Mechanism with an improved delay mechanism using cellulose acetate-based acid ampules that provided more consistent timing. A variant designated Type J featured a larger thermite charge for attacking heavy machinery. Another modification, the Type AP, incorporated a secondary anti-handling device that would detonate if the bomb was disturbed after activation, specifically designed to kill or injure disposal personnel. This last innovation, though militarily effective, generated ethical debate within SOE. The decision to deploy anti-personnel variants reflected the increasingly ruthless character of covert warfare as the conflict progressed. Intelligence assessments conducted by both British and German authorities after the war revealed the true scale of pocket bomb operations. British records indicate that approximately 750,000 Type F devices were manufactured between 1942 and 1945. Of these, an estimated 450,000 were distributed in occupied territories through airdrops and resistance networks. German post-war analyses, conducted by Allied investigators examining captured records, documented over 2,800 separate sabotage incidents definitively attributed to thermite pocket bombs. Actual numbers were certainly higher, as many incidents went unreported or were misattributed to accidental fires or mechanical failures. The cumulative effect on German war production, while difficult to quantify precisely, appears in aggregate statistics. German industrial output in occupied territories consistently underperformed projections by margins ranging from 8 to 15% throughout 1943 and 1944, with sabotage identified as a significant contributing factor. The legacy of the Type F pocket bomb extended far beyond its immediate wartime application. Post-war intelligence agencies on both sides of the Iron Curtain studied the device as a model for covert industrial warfare. Soviet security services developed similar thermite-based sabotage weapons during the Cold War, evidently inspired by captured German documentation on British devices. American Special Operations Forces incorporated pocket incendiary concepts into unconventional warfare doctrine. The fundamental lesson that cheap, simple, widely distributed weapons could force an adversary to expend disproportionate resources on countermeasures became foundational to asymmetric warfare theory. In the museums and archives where surviving examples now rest, the Type F pocket bomb appears almost innocuous. Its compact dimensions and utilitarian construction suggest nothing of its historical significance. Yet this small cylinder of stamped metal and chemical powder represents a profound shift in military thinking. It demonstrated that technological sophistication was not always synonymous with effectiveness, that simplicity could be a weapon in itself, and that the morale and will of civilian populations could be weaponized as effectively as conventional military forces. The German engineers who rewrote their manuals, who created vast security bureaucracies, who diverted precious resources to counter a device costing 2 shillings, understood what they faced. Not merely a bomb, but a concept that struck at the heart of industrial warfare itself. In the mathematics of total war, where every man-hour, every ton of steel, every calorie of energy was accounted for and contested, the pocket bomb proved that even the smallest weapon, properly conceived and widely distributed, could shift the calculus of conflict. The thermite reaction that burned at 2,500 degrees Celsius illuminated a broader truth, that ingenuity and determination, embodied in 4 ounces of metal and chemicals, could challenge the industrial might of an empire.